This instructional video is designed to show you how to use information about isotopes to determine relative abundance when we're given a list of isotopes and an atomic mass. In this case, we have neon-20 and neon-22 and the atomic mass of 20.18. And so there are two facts that we'll take advantage of. The first is simply how we determine the mass, and that's to take each isotope, multiply it by its relative abundance, and add all of that up. And so this then has to equal that weighted average. The other thing we know is that the sum of all relative abundances has to be 100% because that's all you've got. So A% plus B% will equal 100%. Now, because we don't know the value for either of these, we can use the information here to determine what we're going to substitute in. So, if these two add to 100%, let's substitute for A by solving this equation for it. So it's just 100% minus the relative abundance of our second isotope. So we can plug this in over here. So we have that 20 times 100% minus B plus 22 times B is 20.18. So 100% of 20 is just 20. So we have 20 minus 20 B% plus 22% equals 20.18. It's straightforward to recognize that we're going to have to separate the variables and constants. So adding these two together gives me 2 times B%, and subtracting the 20 from both sides leaves me with 0.18. And so now it's straightforward if we divide by 2 that the percent we're going to get for B is in fact 9%. And if the percentages have to add up to 100, we can then determine our relative abundances very straightforward. For neon-20, we should see 91%, and for neon-22, 9%. So this is how we can use the fact that we know that the relative abundances must add to 100 to allow us to determine a relative abundance for each isotope once we have an atomic mass to work with.